Thanks so much. Today I'm going to give a talk entitled Small is Beautiful: How to Improve Security by Maintaining Less Code. I'm Natalie Silvanovich, and I'm a security researcher on Google's Project Zero. For the past year or so, I've been working on JavaScript engines and browsers, and I found a lot of vulnerabilities. But something that a lot of people don't know about me is that before I worked on Project Zero, I actually did product security. I was on the Android security team at Google, and before that, I worked at BlackBerry. And something that I've noticed is that regardless of whether I'm doing offensive work, finding vulnerabilities, or defensive work, trying to secure a product, the same type of vulnerabilities come up again and again. And I think everyone here is in this audience because they want to reduce the number of vulnerabilities in products, and they want to reduce their impact on users. And so today I want to share with you what I've learned about at least one way to reduce vulnerabilities. What I'm going to talk about is attack surface reduction. Every piece of software has an attack surface. This is what an attacker can manipulate, every place that they could find bugs that could harm a user. And obviously, the smaller of an attack surface you have, the better. We've all heard the joke, oh, it's not a bug, it's a feature. But I think bugs and features are intertwined in a more important way. Every bug starts its life as a feature. If there was no feature, there would be no bug. And this sounds a little bit like a joke, because obviously features are important, but it is true. Features are good for users, they're usually useful, but they do introduce security risk. So it's important to make sure that the trade-off is worth it, and that your attack surface is only what's necessary for users to be able to do what they need to do. In particular, I've seen 5 different ways that applications and other software tend to have needless attack surface. There are unused features, old features, code sharing, third-party code, and excessive SKUs and branching. So to start off, I'll talk a bit about unused features. And you'll notice that this slide is missing a cartoon. You see, I wanted to license it, and they said it would be like $5 per presentation, so I said no way. So you just have to imagine that I just said something really witty about product managers putting too many features into a product. But the truth is that all code is a trade-off. It has a security risk and it has a security benefit, and you have to make sure it's worth it. And in particular, if a feature is never used, that trade-off doesn't work. It's just a necessary risk for your users. And I'm going to give you some examples of how this has happened. This is a bug in Adobe Flash CVE 2015-3039, which was found almost 2 years ago, that has a bit of a storied history. So I found this bug, and I reported it to Adobe. And then a couple of weeks later, it was used to win Pwn to Own. Pwn to Own is a hacking contest every year in Vancouver, where hackers are encouraged to share their exploits on certain products and get cash prizes. So this bug showed up again, and then that summer, there was the hacking team dump. This was when an organization called Hacking Team, they themselves got hacked, and all their vulnerabilities were put on the internet. These were vulnerabilities that they sold to malicious parties, and we know as a fact were used to harm users. And this very same vulnerability showed up in that dump. So this bug is kind of special in that we know it was fairly heavily used by attackers before it was discovered. And also, it was found by at least 3 people. So I think it's reasonable to assume that other people knew about the bug as well. So here's the bug. This is the action script that was in the Swift. It's kind of like JavaScript, and it was in a feature called convolution filter. And this feature in itself is quite useful. It's a way to filter images and audio and anything else. But it did have this problem in it. So to start off, you create this convolution filter class, and it gets allocated in native memory. And then you create this object, and I'll talk a bit about it later. but it's basically just an array with an object in it, and the object has a property called value of, which points to a function. Now here's the vulnerability. So it's in the filter matrix setter. So you set the matrix of this filter, and this is an array of floats that's used to set certain filter properties. But when you create the filter, it needs to copy this into native memory. Otherwise, if you, say, change the array later, your filter will change, and you don't want that. So to do that, it starts by allocating the memory for this matrix and has a pointer to it. But then you have a problem. In JavaScript and in ActionScript, arrays can contain anything. They can contain objects, they can contain integers, and in this specific case, the native array you're copying into needs to be floats. So what it does is it tries to convert these objects to floats. And in this specific array, there is one object, and the way you convert an object to an integer is you call value of on it. So you do that, and then here's the trick. You call the setter again. So this will free the memory that the array is in, and then allocate a new one, and then stick the pointer to it. And then this is kind of an OK array. It doesn't need any conversion. So it will write the memory there. But then you still have the old call, which is in the middle, and it needs to unwind. So it will then write to this memory. And at the time, this was a highly exploitable vulnerability in Flash. But there's something I think is even more interesting here. This. Why can you do this? Why are you able to put objects with custom conversion functions into an array that needs to be floats? I would hazard a guess that no one has ever wanted to do this, no developer. This array is meant to have floats in it, and I think most developers will put floats in it. And I'll hazard to say on purpose. I'm sure someone has accidentally used this feature. I'm sure there are Swifts on the internet now where something happened to convert to 0 with a custom function and everything still worked and it's still there. But I would say this is a feature that doesn't provide a lot of benefit, considering the risk that it's caused a lot of vulnerabilities. Here's another example. This is a feature in JavaScript. It's array symbol species. So in JavaScript, there's lots of functions you can call on arrays. And the question that array symbol species answers is, so let's say you have a subclass of an array, and you call a function on it. Let's say you call slice, which is like subarray. Or let's say you call filter. Filter runs a function on every element in an array and then puts it into a new array. Is the thing returned the array or the subclass of the array? And of course, the ECMAScript standard says, why don't we do both? And they created array symbol species, which returns the constructor that is used to create the array that you get back. And this last line is sarcastic. It's easily implemented by inserting a call to script into every single array native call. So to give an example of why this is problematic, we have this bug. So this is in Microsoft Edge, and I'll start at the bottom with the var a equals new myArray. This is creating a subclass of array, which is mixed type. It has objects and it has strings and it has arrays in it. And then you've got a function test, which just returns true. And then you call the array filter on it. This, of course, doesn't know whether to return an array or the subclass of the array. So it calls array symbol species, which then calls into this dummy constructor at the top. And then that will return this array, which is an array of integers. And this ends up being type confusion. It tries to write these objects into the array of integers. So then when you read the integers, it reads the pointers. So that's an info leak. But this is also an overflow because pointers are twice as wide as integers. And this, once again, was a fairly highly exploitable bug. But what I think is also interesting about this is that this is a very uncommon symbol. I did a quick scan of the internet to see, is this actually being used? And I found there were kind of two big players. There's the BBC website, which when you scroll through videos on the website, the array the videos are in has array symbol species on it. There's a brand of athletic wear called Under Armour. Their website uses this. And after that, it's just JavaScript tutorials. Very few websites on the internet use this, and yet it's responsible for at least 10 vulnerabilities. So I have a slide now with a quote on it from Tumblr, which I think sort of describes the problem. If I've learned one thing in life, you can never go back. And this is kind of the problem with these unused features. Sure, it's easy to say no one uses them, you should deprecate them. But once you put them in, even if they're really uncommon, some people start to depend on them. So for example, with the flash object conversion, some Swifts will stop working if they turn it off. Likewise with array symbol species, some websites will stop working, even if it's just a small number. So it tells you that you do need to be cautious with features up front, because once you put them in, they're hard to get rid of. But also, there are a few things you can do to try and avoid this problem. One is to have experimental or beta features. This is a banner from the Firefox website, and they put this on JavaScript APIs that they might deprecate later. And it doesn't really solve the issue that people might use it and their stuff might get broken, but at least they've been forewarned. Another thing is that I'm excited to see that there's been an increased willingness among software vendors to deprecate less commonly used features that have a high security impact, even if the usage isn't zero. For example, this is a message from the Chrome mailing list, and it details the deprecation of various HTML5 events that caused a lot of vulnerabilities and have now been deprecated due to very low usage. And this is a blog entry from Microsoft. It's the Microsoft Office encapsulated PostScript format. This got disabled by default in Microsoft Office. Now if you open a doc, you need to disable it or enable this for it to work. And this is another example of turning off a very uncommonly used feature for security benefit. And finally, this is another Microsoft blog, which is the VB script execution on Internet Explorer 11. So how do you avoid this type of problem? You should base features on user need. That can be easier said than done, but it's a good idea to both find out whether it's likely that a feature will get a lot of uptake before implementing it, and also track features and make sure they're being used. And if they're not being used and have a high security impact, it's a good idea to get rid of them. Also, it's important to be willing and able to disable features. And this is kind of two-sided. On one side, it's willingness to disable a feature. I've definitely talked to vendors who have said to me, we will not disable one feature if it has one user using it, no matter what the security impact. And I mean, that's an opinion, but I try to convince people that there can be a lot of benefit in deprecating things, especially if the number of users is very small and they're not benefiting from the feature that much. Being able to disable features is another thing. And there's a lot of cases to make for modular code, but security is one of them. Sometimes I'll talk to a vendor and they'll say, yes, we will disable the thing. We see that it's really risky. We're going to get rid of it. And then when they go to do it, they'll find that it's too deeply embedded in their systems to be able to do this easily. So it's a good idea to develop features in a way that it's easy to deprecate them for a lot of good reasons. One is if you want to turn them off permanently. But also, if there's a security incident, this can be the difference between, say, disabling your entire website and disabling new account creation. And this is also from Tumblr. Maybe it actually is never too late to do things differently. But, well, unused features do happen. What I think is a lot more common is old features. Developers are pretty busy and don't develop unused features that often. But sometimes features were useful at some point, but then they just slowly fall into disuse, and no one really notices, and they're still there. And this can be risky just because there's no benefit to users, but also if there's not a lot of attention paid to a code, people are less likely to notice there's bugs in there and less likely to fix them. And it also makes them more difficult to fix if they are there, if no one's familiar with the code. Here's an example of a bug like that. This is a CVE that me and Matthias Hurek found in Adobe Flash, and it's a dangling reference issue similar to the one I showed before. But what's interesting about this one is it was the result of a hack made to load macromedia.com in 2003. Just to get the timeline clear here, 2003, macromedia.com will not load. 2017, 14 years later, we find this vulnerability. So, 14 years, it's been vulnerable, and probably 2 years after the hack was put in, macromedia.com became defunct and it wasn't useful anymore. So this is a situation, this created a vulnerability due to something that easily could have been removed because it was absolutely not used. It was for a non-existent website. And it's easy to say that you shouldn't do stuff like that. Obviously, the best solution here is don't hack. Don't put in custom hacks for content because they add up and become error-prone and can lead to vulnerabilities. But I'd say, if you can't resist, it's a good idea to at least file a bug, targeting a release in 1 year to check on your hack. Make sure it's still okay, still doing okay, is still needed. That's one way you can try to avoid especially special content hacks from creating vulnerabilities years down the road. Here's another example of a vulnerability that was due to an unused feature. It was in VirtualBox, and it was found by Jan Horn on my team. It allowed guest-to-host escalation. Here's the code for this vulnerability, and I think the really interesting part is the to-do. To-do, remove this code, it's not useful anymore. Unfortunately, it never got to done, and this vulnerability existed. So this is another example of why it's important to hasten removing unused code, because you never know when a vulnerability is going to get discovered in it and be used. Here's another example. These are font issues found by Matthias Hurek in a number of products. And something he's told me about them that was very interesting is he said that some fonts he found vulnerabilities in, he could not find one example of the font on the internet, not one. So these fonts were useful in the past. I think, in 1995 on your Windows desktop, they were probably used by applications, but they haven't been used for many years, but they were still there causing vulnerabilities. So this is a situation, if they'd gone through, maybe scanned the internet and found which font formats were still being used, they could have avoided a lot of very serious vulnerabilities. So how do you avoid this type of problem? Once again, it's another case for tracking feature use. Make sure everything's being used, or otherwise turn it off. There's a few ways you can do this. One of the best ways is to actually put hooks in your code and see what's being hit and see if anyone hits it. If you can't do that, sometimes there's stats you can get that are a proxy for usage. For example, I'll find myself sometimes scanning the internet for websites as a proxy for what browser features get used. It's also a good idea, compare the usage of something to reported security issues. Quite often, there will be old things that just have many, many issues reported in them, and it can be time-saving and valuable to security to just deprecate them. Also, it's a good idea to track unmodified code. Make sure you prune your code trees regularly and get rid of anything that's not being used. And sometimes it can be useful to refactor code. If it is really old and has lots of problems, but it's still being used, sometimes it can be worthwhile to just rewrite it. And finally, this unfortunately has been cut off of my slides, but it's a good idea to also make sure that all code has an owner. And there's two reasons for this. Number one, every so often on Project Zero, we'll report a bug, and it will take a very long time to fix. And quite often, it will be because they can't find an owner for the code. They'll say, oh, we've asked everyone at our company, the person who owns it left, and we can't find anyone who's familiar. And you want to avoid that from happening. But also, if someone owns a piece of code, someone wants to get rid of owning that piece of code. And that can hasten deprecation quite a bit. So another problem that comes up is code sharing. And there's sort of two sides to this problem. On one side, sometimes code is used for two different purposes with very different attack surfaces. And then if you add extra code for the less serious attack surface, it automatically impacts the more serious attack surface, even though that isn't necessary. That's one problem. But then there's the flip side of this problem, which is sometimes there are too many copies of a piece of code. And then people aren't always aware of all the copies, and they become very difficult to maintain. To give an example here, these are some vulnerabilities that we found on the Samsung S6 Edge. And they were in image processing. And we found out they were due to bugs in a format called CubeJPEG by a company called Quorum. So here's Quorum's website. And you'll notice a few things. They have a long and illustrious history that ends in 2008. And I thought that this might be one of those old unused code situations. But that turned out not to be true. It turned out that Samsung devices actually use this for exactly one thing, which is when you load up your device and there's music and they've got the carrier splash screen on the device, they used this codec to decode that one image. But the problem is that they just plonked it into the Android image subsystem. So now, you're browsing the internet, you're using this image decoder, you're opening an image in gallery, you're using this decoder, you're using it everywhere, even though it's only necessary on this one attack surface. So I think that if they had reduced the attack surface here, if they had just allowed this image decoder to be used for this one thing and nothing else, this wouldn't have even been an issue. Because if you've got enough access to the device where someone can swap out this image, you've got big problems anyhow. But because they extended it to all these other features with enhanced attack surface, this vulnerability in this code suddenly became quite serious. So here's another example. This is the example of the flip side. These are issues that were found in Android WebView. If you don't know, the Android WebView is the component of Android that's used to parse HTML and JavaScript. And when I was on the Android security team, many vulnerabilities were reported in this. And quite commonly, they were fixed in one place and not another. Applications would embed their own WebView, and that wouldn't get fixed. And then there were multiple copies on the core device. And this was eventually fixed by having a single copy of that code. And the reason this was helpful is because it generally had the same attack surface regardless of where it was used. So it made a lot of sense to make it so that there was only a single copy on the device. Another thing where this came up was the font issues that Matthias found. You see, the reason he had to have a chart like this with different problems and different vulnerability numbers on different products is because a lot of products had multiple copies of the same code. And then the same vulnerability would show up there. And this is another situation where if they'd reduced the numbers of copies of the same code, it would have been much easier to fix these vulnerabilities. It would have made it much faster to patch. So how do you avoid these types of issues? One thing is to make sure every attack surface only supports the needed features. In particular, if you have a remote attack surface and you have a local attack surface, make sure that adding stuff to the local attack surface won't add it to the remote attack surface unless that's actually useful to your users. It's also a good idea to avoid multiple copies of the same library, because these are always difficult to maintain and it will cause issues with patching. Now I'm going to talk a bit about third-party code. And third-party code is a common cause of needless attack surface. And there's a few different ways this happens. There's misuse, extra features, lack of updates, and unexpected interactions. To start off as an example of a problem with third-party code, this is a vulnerability that me and Tavis Ormandy found. And basically, it was 666 because that was actually the bug number in the tracker. But what happened is Tavis was looking at this FireEye network appliance, and he discovered they were using a Java decompiler called Jode. And he thought about this, and he wondered, was this ever intended to decompile jars on the network interface, which is what it was doing? So he contacts the developer, and the developer says, no, I never intended it for that. It, in fact, executes the code as it decompiles it. So I wrote up a special jar that used this feature, and it was very true that if you sent this special jar file to the network interface, this network appliance would just execute it, and you could get full access to everything. So this is an example of not adequately looking into third-party software. I think if they'd, decided we're going to use this component and thought about what attack surface was it intended for and what attack surface are we using it for, they would have either chosen to use a different product, or they would have decided that they should fix this so that it doesn't execute code anymore. So here's another example. This is a bug that was found in the Linux kernel, and it's actually a positive example of where things could have gone wrong but didn't. So this vulnerability only affected Linux, and the reason it only affected Linux was because Android didn't define a flag that was needed to make this feature available with lower privileges. So it didn't affect Android. And this was good design, both from the Android perspective and from the Linux perspective. It was good from the Android perspective in that they actually turned this flag off. And it was good from the Linux perspective that they actually support the feature where you can turn off features you're not using. And I would say this is something you should look for in third-party software. It's always good if they allow you to very easily reduce your attack surface to what you're actually using. This is something that happened a lot when I was on the Android security team. happened that many third-party libraries were not updated. You name it, it wasn't updated. There was the WebView, Media, Qualcomm, Linux, all those sorts of things. And as I was on the team, we moved to different systems that allowed us to update these more frequently. Because the truth is, if you have a third-party library with a vulnerability in it, why would an attacker ever bother trying to find a vulnerability in your product? Because they already have free vulns. So it's really important to try and avoid having free vulns for attackers by not updating third-party libraries. Actually, something someone said, which I found amusing when I was working on this project, is, a puppy isn't for Christmas, a puppy is forever. And I think that's actually a good analogy for third-party libraries. You know, when you get them, they are new and exciting, and you love them. But then as time goes on, they require a lifetime of maintenance. You need to push those updates every month. So it's important to realize that when you put third-party software into your product, you are kind of inextricably linking your future to their future. Like, yes, you can get rid of the product if you want to, but really, any decisions that get made about that library will have an impact on you. So it's important to figure out what it's intended for and what the future of it will be and how it gets updated to make sure it's the third-party product that you want to use. And finally, I'll talk about this project that James Forshaw worked on. This is an example of how you can make a product more resistant to the security implications of another third-party product. In this case, Adobe Flash often has code execution vulnerabilities in it. But in themselves, these aren't useful to attackers. Attackers need to get out of the browser sandbox to really be able to do something useful or access a user's data. So what James Forshaw did is he worked with engineers at Adobe to remove all the calls to Win32k in Windows. And then once he did that, then they were able to turn on a flag that made the binary not able to access this Win32k API. And this reduced the attack surface because now, if you had code execution in Flash, you couldn't call into this more vulnerable API and start looking for vulnerabilities you can use to get out of the application sandbox. So this is an example of Adobe insulating itself from vulnerable aspects of Windows. So how do you prevent these types of problems? One thing you can do is track third-party software. I think every company should do this. It's very important to know what you have and where it's used, so you can easily make sure that you can update the software if there's a serious vulnerability. It's also a good idea, for a lot of reasons, to have an internal process for use. Some of the worst problems that we've seen on Project Zero is when a developer just takes a library and copies and pastes it and never tells anyone. Then it can be really problematic if you have a vulnerability or other problem, because you don't even know you're using that code. It's also important to trim unnecessary features. A lot of good libraries will give you the features you need to say if you're only using one image decoder, not to make every single image decoder available. And finally, it's important to security update frequently. And I do want to say here that I'm not opposed to third-party libraries, despite giving you all these cautions. I think if you're doing something, for example, decoding images, and there's very mature, very security-tested libraries out there, that's usually a much better option than creating your own library. But it's also important to be careful and not just plug-and-play third-party libraries, and make sure that you truly understand the security impact. So the last thing I'm going to talk about is excessive SKUs and branching. A SKU is a stock-keeping unit. If you sell devices, every different product on the store shelves has a SKU. And if you make software, software is often branched into independently maintained versions. And both of these make it more difficult to security update, and they can introduce bugs, and you can have patching problems. So this is a page from a Dr. Seuss poem called Too Many Daves. It tells the story of Mrs. McCabe, who made the time-saving yet ultimately short-sighted decision to name all her sons Dave. And now she has problems. She calls Dave, and they all come. You know, she can't tell them apart, and she didn't even give them support periods, so they'll just stay in her house until they decide to leave. And this is what will happen to you if you have too many SKUs. So I'm going to give some examples of vendors who had skewing or branching problems. And in this situation, I have anonymized the vendor because they told me some of this information in confidence. So to start off, we have vendor number one. And vendor number one is a large software vendor. They make most of their money off of software, although they do have the occasional piece of hardware they make. And we had two problems with them. Number one was that we would find bugs in one of their products that would affect another one of their products, but it wouldn't get fixed in both. And of course, the way this happened was because they had so many branches, sometimes far more than I thought was needed for the differences between the products they had, it would become very error-prone every time they patched. And sometimes this would cause them to forget a patch and leave people vulnerable. But then another thing happened that I was very surprised about, which is they forgot to fix a vulnerability. And they told us it was fixed, and we started talking about the bug, and then it turned out the bug was not indeed fixed. So I asked them, how could this happen? And it turns out they have this really large, excessively branched build system. And then at the bottom are all these tiny hardware products that there aren't even that many more in existence. And it's all connected, and if you put in a change, it builds for a long period of time, finally coming out the bottom. And if any build breaks, they got to pull the patch. And then they got to start building over. So this happens, they patch our bug, it's building, they tell the security people, yeah, we're patching the bug, and then they tell us, yeah, we fixed it, and then the build breaks. And then someone pulls the fix, and they don't fix it, and they forget to tell us, yeah, we pulled the fix. Which, I mean, that was a mistake, and these things happen. What I think is more interesting here is this shows that they are delaying security updates by months because of this build system. I really do think if they had fewer branches and fewer SKUs, they would be able to deliver security patches much faster. Now, this is vendor number two, and I do want to give a caveat here. Every time I give this talk, someone comes up to me afterwards, we're vendor two, aren't we? So I'm going to assure you, vendor two is not in the room right now, but if you think this might be you, maybe you should think about putting some of these recommendations into effect. So vendor number two makes only devices, and they make 365 SKUs per year. This is one device per day. We found a number of vulnerabilities that affected all of their devices, and they had a lot of trouble fixing them because they had so many SKUs. They couldn't fix the bugs in 90 days, not on the 2,000 devices they've made in the past 4 years. They couldn't tell us a fixed date because with so many devices, it's all different days. And they couldn't tell us fix saturation. We asked them, so when do you think roughly 50% of devices will be fixed? And they said, actually, we think that is inherently unknowable. And this is what happens when you have quite so many devices. And recently, they have started working on a project to greatly reduce the number of SKUs they have because they've started to realize what a serious maintainability problem it is. But this also is an example of why it's important to have support periods. This specific vendor did not have any on a lot of their devices, and this makes this process a lot more difficult because they just have to wait until people stop using them. There's no point at which they can say, we can just declare all these products dead and stop working on them. And this will make it much more difficult to fix this problem in a reasonable period of time. So here's another example. This is a vulnerability that Ben Hawks on my team found in a Qualcomm GPU driver. And what was interesting about it is that Qualcomm had also found this issue, and they had fixed it in their branch. But Android never put the branch into their software. So this is another example of how having lots of branches that need to have stuff pulled into them is inherently error-prone and will lead to some vulnerabilities not being fixed. Another example is this is how Android 7.0 shipped with low-entropy ASLR. So what happened is there was a fix that came in from Qualcomm, and it got merged into many branches, including Android 7.0, except it had a conflict in every single branch. So someone had to go through and manually resolve every single conflict. And this happened, and then once this was released, someone reported publicly that we had this reduced entropy ASLR. And it turned out that when the merge conflicts were resolved, they accidentally undefined something that reduced the ASLR entropy. And this is is another example of how having lots of branches leads to inherently error-prone processes that can cause vulnerabilities to either be added or not be fixed. We resolve this by adding tests, and tests can save you a little bit if you have a lot of branches and a lot of SKUs, but it's not the ideal solution. Still, if you know you have to branch a lot or have lots of devices, it's a very good idea to have robust testing, so at least you know you can add fixes without breaking things. So how do you avoid these types of problems? Avoid branching and avoid SKUs. I know this is easier said than done, but it's a good idea to cut down as much as possible because it makes maintainability very expensive, especially from a security perspective. It's also a good idea to make it difficult to branch. Developers shouldn't be making this decision on their own. It should be a decision made by software development that it is necessary to have a branch. It's also a good idea to have a documented support period for every branch and every SKU and every product. It, once again, doesn't solve the problem that you're cutting people off, but at least it means if you mess up how you do this really badly, it gives you a time period at which you can turn it over and start over and do branching and skewing in a different way. Finally, for a lot of reasons, it's a good idea to robustly test every branch and product. So that's it. In conclusion, you should consider the impact of security features in design, or the security impact of features in design. And it's important, in particular, to think about what sort of security risk you're introducing and whether it's worth it to the benefit you're adding to users. It's also important to track feature use and remove old and unused features. You should carefully consider all third-party code you use and keep it up to date. You should reduce SKUs and branches wherever possible and have a clear support period for every product. So I'm going to end with Smokey the Bear. Only you can reduce attack surface. I know a lot of stuff I've said today is a little bit basic, but what I will say is it's a fair representation of the vulnerabilities we see on a daily basis. So I'm hoping that every one of you can think of one thing they can do differently to reduce attack surface in the software they develop. So thanks a lot, and now I have time for questions.
I have a question. When you do your research, how much of those vulnerabilities are because developers actually put extra features into the code that they were never asked to put in there, in your experience?
That's a hard question to answer just because I don't know if the developers were asked to do it or not in lots of situations. But I would say a lot of vulnerabilities are at least due to features that never get used. I would say, conservatively, maybe 1 in 20 vulns I find are like that.
Hi, you mentioned that there was one vendor who claimed they thought they fixed some security defects, but they actually didn't, and it was a failure of the build process. But so that implies that they actually didn't test after the build for the original vulnerabilities. Is that common?
Yeah. I'll admit I was a bit surprised by that because I knew this vendor usually does that, and I'm not sure what happened in the situation. But it is fairly common for vendors not to test or not to test well after reporting vulnerabilities, fixing vulnerabilities, and I think that's really important. It's also fairly common for vendors to get back to us and say, oh, can you verify for us that the vulnerability is fixed? And I think that's always a good thing to do if you can, to provide the fix to whoever reported the bug and get their opinion on whether it's fixed or not. Okay, I guess that's it. Thanks a lot.